Well, good afternoon, everyone. Thanks for coming. My name is Dan Meyer. I'm operations manager with a company called Photronics. We're a manufacturer of photomasks, which are a critical supply chain part for semiconductor manufacturing. Over the last couple of years, we've actually gone through about a 2-year-long process of trying to tame our data. It's been a very difficult process, a very arduous process, but I wanted to take a few minutes of your time to share some of the insights that we learned along the way. Manufacturers in general collect lots and lots of data, but we don't use it very effectively. We do tons of different kinds of things with data, and data comes from many, many different kinds of sources. We've got data from our shop floor system, the manufacturing execution system, asset management systems, inventory management systems, material handling systems, industrial control systems, these are sensors in the building and things like that, tool control systems, process control systems, inspection systems, sales and customer management systems, accounting, financial systems, and really many more. So lots of different places. Everybody has lots of data in their environments, but manufacturers tend to have more because we cover not only the manufacturing portions, but we still have to run a business. So we have all the finance sides and the marketing sides and the customer and sales sides on top of all of the manufacturing things. So the interesting thing is that as many data sources as there are, we retrieve using data using nearly as many methods. The means of getting this data really matches the number of the sources. So we're getting formatted and unformatted text files, so these could be log files that are coming directly from the tools and from other systems. We've got serial data streams. SEX is the Semiconductor Equipment Communication Standard. I'm not ashamed to say that I am a SEX worker. So we have SEX communications, which are communications directly from our tools. We have data ports from tools and also all of our industrial systems like DI water systems and things like that. We also have wired network systems, so SCADA systems, HSMS, which is basically a high bandwidth version of SEX communication. Interestingly, a little tidbit, HSMS uses TCP/IP and they called it SEX messaging under TCP/IP or SMUT, but the Standards Committee quickly rejected that notion. Wireless network streams are becoming more and more predominant, so we've got discrete sensors, primarily Wi-Fi, but also we're beginning to see a proliferation of Internet of Things applications coming from RFID, Bluetooth Low Energy, Zigbee, Z-Wave, other things like that. So transforming all of this data into something that's usable, something that's meaningful is really the trick. Manufacturers tend to be all over the map on what they do with the data they collect, if in fact they do anything with the data they collect. Well, a lot of times we simply save the data into a variety of repositories for quote-unquote future use. It's something that we're going to save it. Maybe we'll do something for it, but gee, if we need it, it's there, and we typically don't use it for things. We may be able to save those files in the original format. We may parse the data from the files and save them in a modified format. We may import the files or import the data into Excel or another CSV format, and we may actually stuff things into a database. Well, that's handy, but again, it's just data. We haven't done anything with it. We haven't made any information out of it, let alone create any insights. A lot of times we actually use a subset of the data for end-user reports, typically in Excel or JMP, something like that. These are decent tools for ad hoc data analysis, but really there's a lot of overhead in order to get the kinds of data that you want and to be able to create any kinds of insights. It really narrows the range of operations that you can do on the data. And blending data from different sources becomes very difficult, as I'm sure everybody knows. So really, it's typically not very easy to scale these or to reuse these data sets. And finally, from the typical manufacturing paradigm, if you really want something done right, you go to the IT folks, and they'll craft up a custom report for you. Well, that really ignores the fact that the IT folks are typically underworked or overworked and overtasked, and it really kind of ignores the idea that a lot of what they're doing, because they don't know the problem domain very well, the reports tend to be pretty static. So you can see a snapshot, but that's okay. You could throw it into a PowerPoint and it's going to be the same the next day, and that wouldn't be any different than the report that they're giving you as a web report. So really there's got to be a better way than this. Formal analytics efforts have traditionally been met with resistance, however, within manufacturing companies. These trends tend to be a strong sense, there always tends to be a strong sense of the way we've always done it is just fine, it's satisfactory. Anything beyond the standard solutions, beyond what we've always done, is considered risky. So, in the spirit of David Letterman, I've created the top 5 reasons why manufacturers resist data analytics efforts. Number 5, we've already got lots of data. We don't need to spend money on any more. There's a fundamental misunderstanding that data analytics is simply about getting more data, when it's really about using the data that we've already got. We tend to be data rich but information poor. Number 4, that's the way we've always done it. This is very, very strong within manufacturing organizations. The perception that the status quo is good enough, but you don't know what you're missing if you don't know what you're missing. You don't know the insights that you could have if you just don't have the perspective of knowing what they could provide. Number 3, Sonny boy, I've been in this business for a long time and I know what's going on. I have an intuitive sense. How many people have heard that? Probably about 1,000 times a day. You ever heard of HIPPO? The highest paid person's opinion? We see that all the time. These are the people who tend to be in the senior positions and the people who tend to make the capital expenditure decisions. So we kind of have to listen to them. Number 2, my engineers will get me all the data that I need. Manufacturers tend to be an engineering-centric crowd, and we've got lots of engineers, and so if a manager needs data, they'll just go to the engineer to get the data that they need. However, that kind of ignores the fact that the engineer is probably spending every bit of time before the deliverable that the manager asked for to get the information, to slap it into Excel, to create the pivot table, to massage out the charts, to slap it in the PowerPoint, only in time for the manager to get it by the time he walks into the meeting. There's really no time for discovery, no time for insight for that information. And the number 1 reason, hey, the IT group will code me up something if I really need something fancy. Well, this ignores the fact that analytics really isn't an IT effort. The business has to be involved with this. If you've ever written reports and analytics with a group, especially a remote group, an IT group, it becomes an iterative effort. You give them a description, what they want, they code something up and send it back to you. You say, yeah, kind of, but I need this and this and this. It's not really what I need. And you send it back to them, and it kind of goes back and forth across the fence a number of times until you finally get most of what you want. Probably not all, but most of what you want. And even then, it tends to be pretty static in nature. It's repeatable. It'll update with today's information, but you can't do any investigation from it. So these are the top reasons why we see so much emphasis to do things the way we've always done it, because there's a lot of resistance that's coming from manufacturing. Well, we resist change because we don't know what we don't know. So transforming the mess of data that we routinely collect into a useful asset really has to be a process. It has to be a very, very focused and considered process. So with that in mind, it's really critical to define goals to help provide focus to that process. So the goals that we found to be the most important, first of all, was to create common data sources and definitions. We need to get to a single source of truth. Everyone needs to reference the same data. Have you ever gone into a meeting to discuss, say, cycle time? And you got 2 or 3 people who bring charts into the meeting, and you're all presenting your charts. It should be the same information. It should be the data, same data. But instead of talking about how to improve cycle time, you're talking about why your data is wrong and my data is right, and everybody's pointing fingers back and forth, and you're spending your time defocused trying to figure out what the differences in the data are, not trying to solve the cycle time problems. This comes from having too many sources of data. We really can't focus on what the problem is if we aren't all on the same page from a data standpoint. So getting to a common source of data is very important. Second is data consolidation. We want to make a common location for all of that data. Ideally, your users should be able to go to one place to get all the data that they need. Typically, in our environments, we have many different data sources. Again, some of it's coming from files, some of it's coming from Excel spreadsheets, some of it's coming from databases, and multiple databases. It's all over the place, all over the map. And if you've got a power user, we all know about the power users, the power users are kind of going all over the map to try to pull that together into something that's meaningful. But again, multiple data sources, because they're massaging the data into their own little Excel spreadsheets and doing some additional analysis on things. And now when you get some data that's presented within an engineering meeting or in a production meeting, you kind of don't know where it really comes from, and you haven't been able to formally vet the process, that the analysis that was behind the data. So being able to get the data into a common location where everybody can reference it, everybody's got the same data, is very important. Being able to democratize access to the data. This is critical for us. If you've got 100 engineers, out of those 100 engineers, maybe 20 of them will know how to write a SQL query. Now, we're going to leave it out of the way for a second that probably more than half of those SQL queries are going to be really inefficient, and some of them will probably bring down your database. We'll set that aside for a second. Only 20% of the users who need that information have the capability of doing the coding, data mining to be able to get to it. And probably only 3 or 4 of those users have a login to the data sources. A lot of the data sources that we use in manufacturing are within the scope of SOX, so they're protected information. The IT group doesn't want to let them have it because they know that they'll crash the database. The compliance group doesn't want to let them have it because it's SOX-specific data. So we've only got a couple of people out of the entire set of people who have the ability to get the information that they need. What do the rest of them do? Well, the rest of them are creating their own little spreadsheets or making up the information on their own or something else. So democratizing the access to the data is very important. How can we get everybody access to the correct data, to the consistent data? And finally, common metrics definitions. If we have a definition for yield or for cycle time or for any other manufacturing metric, we want to be having everybody in the company use the same definition, the same metric, the same calculation, the same underlying assumptions for that metric. Otherwise, again, you spend all of your time at the meetings defocused on talking about the assumptions and the underlying data, or trying to search down problems or differences between different manufacturing facilities, their yield performance or their cycle time performance. Gee, why are they so different when maybe they only had a different calculation? And you may not know that from the presentations. So common data sources, common metrics calculations are all very critical. So for us, what we found, these are the really key goals that are central, of central importance to really work on as a part of a data analytics project. For us, from an operational perspective, we chose to focus on 4 key areas of analytics. These are key use cases that help us to drive improvements to the business. The first is, how are we doing? These are the snapshot of a point in time that let us know what's going on in the factory. The second is what we call canary in the coal mine. The canary in the coal mine hopefully gives us some predictive measure about what's coming up around the corner so that we can at least be aware of and hopefully avert catastrophe. Mashups allow us to bring data in from different systems and different data sources to be able to hopefully create a larger picture that will give us a more complete idea of the environment. And finally, the ability to look beyond the obvious. So we'll talk about these in in brief. The first, how are we doing? Again, the goal is to understand how things are going in the fab. Are they going well? Are they not going well? We want to be able to know what's going on. So we'll look at a couple of examples. We want to be able to provide the ability to see the forest despite the trees, and we want to be able to transform the loud voices of complaint, everybody who's saying, oh my gosh, the sky is falling, into a broad but realistic picture of reality with this. So if you take the example, high-level example of how many widgets did we ship, it doesn't really matter what it is. Everything, the examples that I'm going to use today are all in widgets. We all make widgets, right, of some form or another. So for us, it was important that we start with questions. So the questions really revolve around how many units did we ship, what's the trend, and where were the numbers with respect to the goals. So we create a chart, a viz that looks pretty typical. We've got a bar chart that shows the individual units that we shipped on a monthly basis. We've got an orange line that shows us a 6-month moving average, so that's our trend for things. And again, you can use all sorts of different kinds of trends. We just found that a moving average was the best way to smooth out the data, to look at our baseline capabilities over a longer period of time. And then we've got a dotted line in there somewhere to show us what our forecast was. So now we know how we're doing on a month-by-month basis compared to forecast, but from a longer-term smoothing perspective, capability perspective, we see how we're doing compared to that forecast as well. Here's another quick example, yield. We all know yield information. We're asking the question again, how effective is our manufacturing process? What's the trend? How does that compare with our goal? And so we can have a line that shows our raw information in the blue line, that's our monthly information, a long-term trend, again a 6-month moving average against our goal line. In this case, yield, higher is better. We can see very clearly, very quickly that we're above the goal line, so we know, great, everything is looking really, really good in this particular situation. Cycle time is another really common metric for manufacturers. Same kind of questions. How long does it take us to manufacture our widgets? What's the trend? What's our goal and how are we doing compared to our goals? And so we can do the same kind of chart. Again, we're looking at raw information on a month-by-month basis, a long-term moving average. We can compare it to the trend. And here, cycle time, we want to get lower and lower, so we can see that through this example, we are above the goal line. So that's not a good thing. So we need to begin to ask some questions. All right, what's going on? How can we reduce cycle time? So the whole concept of how are we doing, we can see snapshots of our current metrics, but these are kind of fragmented snapshots. They really don't tell you anything about anything else, and maybe there are some relationships that we can find, particularly if we put all the information together. So it's possible, very easy, to create a dashboard where we can kind of line these up on a time scale, and now viewing the data together can really help us to see some associations that we otherwise might have missed. For example, what happened in January? We see that cycle time spiked, yield dipped, and we had a peak in our units shipped. Maybe there's a causal effect going on there. Something certainly that prompts some additional questions that we might not have asked by looking at each of those charts in isolation. Well, the takeaway from all of this is that we want to build charts to answer questions. So think of the questions that you want to ask and then pull in the data to be able to deal with those questions. We want to add trends to the data to show whether those periodic dips or spikes in the data are meaningful or whether they're just momentary blips. And finally, grouping the trend charts can help us to spotlight problems and hopefully solutions as well. So the next area of focus is what we call the canary in the coal mine. That's hopefully to give us early warning about what's coming up ahead. It helps us to prepare for and hopefully prevent future problems. The trick is to look at the data beyond the normal ways of looking at things. We want to be able to find some predictive insight. And often the best insights are right in front of us, but just a little bit out of sight. So we have to dig a bit in order to find them. Here's an example that we use in our manufacturing area, a very simple dashboard. The first chart that we use is simply WIP. So work in progress over time. These are organized by day. And our manufacturing staff looks at this on their daily manufacturing meeting to kind of see how things are going in the factory and look at the trend over the last couple of weeks. In this case, we can see that there's a little bit of fluctuation in WIP, but there are no spikes in WIP, there are no dips in WIP. Everything looks fairly static, fairly constant. The next one that we look at is the percent on time. So every widget that we build has a due date when we need to finish that in order to get it to the customer on time. And so we simply say, okay, has this particular widget met its due date, yes or no, and we can develop a metric out of that. So in this case, again, we're doing pretty well. We're typically above 90% on time in the factory, and that's pretty good. We have a goal of 90%, so, and again, it's flat. We don't see a trend going in any direction. It's not going up, it's not going down, it's pretty constant, so steady state. We have another metric that we look at, which is the mean time at step. Mean time at step gives us a lot of information about the velocity of the factory, how things are moving through the line. If the mean time at step is increasing over the factory, we know that things are slowing down, perhaps WIP is building up, and that we need to do something in order to maybe remove a bottleneck or to keep things moving throughout the manufacturing area. But again, in this example, things look fairly flat. Maybe there's a little bit of a trend up, but there's no spikes. There's nothing that is really terribly alarming. So from these three metrics, we look at them and say, everything seems to be okay in manufacturing. But we've been burned by this before. We've had these excursions, cycle time excursions in particular, and we had to really look at the information to figure out, our metrics seem to show that we're okay, what's going on. So we came up with one additional metric. And this is a metric that we call the average hours ahead or behind schedule. So in our manufacturing system, we're able to take the sum of the mean time at step, or the remaining steps in the process flow, in order to estimate the time that an individual widget will finish in manufacturing. So we can predict that time when it's going to finish and compare that to the due date for that widget. And then the number of hours, if it's ahead of schedule, turns out to be a positive number. The number of hours, if it's behind schedule, turns out to be a negative number. So even though the individual widget may be only a third of its way through the process, we can already determine whether it's ahead or behind schedule. Average that out through the entire manufacturing area, and now we have a predictive metric that can show whether the manufacturing area is starting to get behind schedule. And in this case, you can definitely see the very precipitous downward trend with things. The interesting thing about this, we could see that the fab was getting behind. We didn't have this particular metric over this set of data, but the interesting part of this was that in the next 3 days of data, beyond what you see in the first three charts, all of those numbers just took off. So the WIP increased a lot, the percent on time went way down, and the mean time at step went way up for things. We couldn't see it unless we had this final metric, the average time at step information. It was really our canary in the coal mine to help us see that problem. So this was a specific data set that we learned our lesson on, and we've been able to implement that in manufacturing and use it really very, very productively to help us not get into situations like we found ourselves in that case. So the takeaway, first of all, the normal ways of looking at the data that give you the snapshot of how we're doing really don't give you clues about what's coming up, what's ahead. Predictive measures are really the canary in the coal mine to help us avoid those problems coming in the future. We want to be able to integrate those predictive measures so that everybody can see them. It's not enough just to be able to do them in abstraction and maybe share them in a morning manufacturing meeting, but to make sure that they're pushed out and published to everybody so that everybody knows, uh-oh, I need to do something about this in my area on my tool set. Next, we have mashups. Mashups helps us to go beyond the traditional dashboard. It takes data from completely unrelated data sources. We blend it, we overlay it, we slice it, we dice it, and we try to get something that is ultimately greater than the sum of its parts. Insights really can come from many, many different directions. You have to really be a keen observer to see them, however. Sometimes you need to pull seemingly unrelated things together in order to understand the big picture. And if you're really, really clever, you really can have a synergy through all that information that helps to show you something that you otherwise wouldn't have seen. So let's take a look at yield again. We saw this slide before. And once again, we start with questions. The question I have when I yield with this slide is, what happened with yield in January? We see a dip in January. I want to know exactly what happened with that. In our environment, we're able to develop an event database that stores simple information about the events that occurred in manufacturing. It doesn't store a lot of detail. It just says, okay, we had an electrical alarm or a static air pressure alarm, or just basic information. Maybe a recipe was changed, or there was a preventive maintenance on a particular tool. Basically just events that happen in the fab. And what we're able to do is overlay those events with our yield information in this case to see if we can find that smoking gun. We're trying to isolate the problem to see if we can figure out the events that were happening at the time in question, in this case January, in order to be able to see what the root cause for this particular excursion was. So in this case, we are focusing on January, so those are the events. We're really able to home in on the events of the time that we had the dip in yield. Tableau gives you a really neat capability. If you click on something in the legend, it highlights everything on the chart, on the viz, and everything else kind of fades into the background. So we've been able to do that here. We've highlighted the first thing, which is an air pressure alarm, and we can see 4 big bright green lines in the events section on the top that stand out. And the first thing that we can tell from this, very easy to tell, okay, we didn't have any air pressure alarms in January, so there's no correlation there. We can go through the rest of the list and see if there's something going on, and in fact, we sure see that, in January we had a major repair. So we're able to pull some additional information to be able to put into a tooltip about this major repair, and we could see that it came from a tool called Proc02, and Proc02 had they replaced a chemical heater and injector pump. Now, I'm not exactly sure what that is, but it sounds pretty significant to me. So that begins to lead us to some more questions. Is this a smoking gun? Well, repairs happen all the time, but they don't usually cause yield excursions. But let's see if we can drill into that particular tool. The tool was Proc02, so we have the capability, because it's just an attribute in the database, we have the ability to be able to drill in on the events for Proc02, and here's what we find. So we can see that there are some PMs. You can see those pretty evenly scattered about, quarterly PMs. And you can see that there was a PM that was overlaid with that major repair, where all the text is kind of jumbled together, and it looks like there were some process changes on either side of that major repair. So right in that time frame that we're looking for in January, we had some process changes. So again, we can look at the tooltip information. The first process change said changed rinse process 32. Okay. Recipe changes go on all the time. A lot of times they'll see that something is shifted about the process, and they need to tweak the process a little bit in order to get the metrology back in. That's probably what happened in this case. Shortly after that, they did a preventive maintenance. Well, let's look at the second recipe change. That one says restored rinse process 32 to original. Uh-oh, here's the smoking gun. What happened in this particular case was that after they had changed recipe 32, they had a preventive maintenance. They found a major fault in a system. They repaired the tool, the injector pump, and then they found, after they qualified the tool and sent it back into production, that the metrology looked really bad. And what they found is that the process change that they did before the major tool change actually would have driven the tool out of spec, out of control, with respect to the corrected tool if that injector pump would have been behaving correctly. Once they replaced, but they basically, using the process change, brought it back in into alignment and into control. After the tool change, it pushed it back out of control again, the process and the metrology out of control, and so they had to change that recipe back to where it was before. So the neat thing about this is that the database for this is really simple. I mean, it's just, hey, enter the tool, enter the time, enter what it was that happened, and throw a category on it like a tool change or a process change or a PM. And it takes about 30 seconds, literally 30 seconds to do. And if your engineers are like my engineers, it's really difficult to get them to do anything, but typically they'll do something in 30 seconds. I mean, we're all busy, right? But 30 seconds is to provide this level of analytics and this level of correlation is really, really a powerful thing. So for us, it worked really extremely well to be able to determine that smoking gun and mashing up different data from different sources in order to determine what our process problems were. Before, we may not ever have been able to figure out what the problem was. And now we have a vehicle to be able to do this very quickly and efficiently. So the takeaways for this: first of all, data mashups can be the quickest way to find the smoking gun. In manufacturing, time is typically the common frame of reference in a lot of other data. Geospatial information. In fact, all the demos that we saw in the keynote this morning were geospatial information. We want to look at the housing price by zip code or in certain neighborhoods or cab fares or that sort of thing, all with respect to geolocation. But in a manufacturing area, we frequently don't have any kind of location information, and that's really not what's driving our process. What's driving our process is time. And so the common framework to be able to overlay different sources of information is time, and that's typically how manufacturers work. But the caveat with that, we have to be careful when we're using time as the aggregate. The event information that we had is day-based information, whereas the yield information that we had was month aggregated information. So it's possible that depending on how you overlay that information in the dashboard, you may be making some assumptions about what occurs within that one data point in the month metric that really was out of scope. So you have to be sure to line everything up, and a lot of times, at least in the way that Tableau exists today, it's difficult to lock the axes, the reference axes, if you're really talking about different charts, different vises laid together in a dashboard. But definitely, as you can see from this example, it's well worth doing. Next, we want to look beyond the obvious. For us, this was the most important thing. Sometimes we just need to look deeper. We really need to look for that needle in the haystack. The answer to the problem tends to be elusive in many cases, so we need to pull apart the data to figure out exactly what it is that we're looking for and to try to explore the problem space a little bit. So here's an example that we've used regarding on-time performance. So we're simply asking the question here, what if we had more time? So our metric says, I only shipped on time 80% of the time. So this is a particular product line. 80% of my orders were on time. Now, we had a long-standing goal for this particular product line of 90%. We can see the goal up there. We can see our performance to the goal. But, 10% improvement in a manufacturing area is really quite a lot, especially you can see the aggregation here is over a year. So we were performing pretty consistently at 10% below goal. So the big question is, what do we go on here? How do we figure out? We've been doing this for a long time. We've been making some incremental improvements here and there. We've been trying to tighten up the process, but we're still 80%, 80%, 80%. What can we do to improve this? So the question is, what if we had more time? If we had more time in manufacturing, if we had more time, would it be relevant? Well, Tableau lets you create calculations that can answer some of this data. So we simply said, all right, instead of the actual due date for each of the widgets that we built, let's say that the actual due date was 1 day later. Would that make a difference in what my on-time rate was? So we came up with that metric, plotted it. Wow, there's our 10% right there. Well, hey, if 1 day is good, 2 days must be better, right? So here's 2 days, here's 3 days, here's 4 days. Okay, we're definitely hitting the diminishing returns at this point. 1 day really was the sweet spot. That's going to give us the big bang for the buck. So it began to help us focus the question. We're missing a big part of that margin, that 10%, simply on those widgets that are just a little bit late. You know, the ones that are 30 days late or 7 days late or something like that aren't the big problem. It's the ones that are 1 day late that are really keeping us under our goal. So that gives us really a place to focus the conversation. It really gives us a path forward for how to analyze the data. So now we have to get down into the weeds. We've discussed the scope, figured out the scope of the problem, we figured out a path forward, so we need to figure out what's going on. All right, here's some on-time performance analysis data. I love this chart just because it's so unintelligible. It's just, you know, hard to tell what the heck it is. Well, on time can be quantified by the number of days shipped early or late. So we really want to focus on the orders that are late, really. So let's look at an example. Let's just take this particular data point. In this particular data point, based on the x-axis, which is the required turn time, that is to say how long our customers gave us to build the widget, the customer wanted it in 25 days. And we shipped it 4 days early. So we're in good shape. And you can see that there's a dotted vertical line on the left of the dotted vertical line. It's kind of a red colored background. Some people say it's gray, but it's supposed to be red. And everything on the right of that is green. So everything on the left of the dotted line are widgets that we shipped late. Everything on the right side are widgets that we shipped early. And you know, the encouraging thing with this is, wow, we shipped a lot of widgets early, which is really terrific, but we really have to address the widgets that we shipped late. So again, start with the question. What is it that's making us late? In this case, we really need to focus on those widgets that were 1 day late. So that helps us to focus the conversation. Again, we don't necessarily have to look at the things that were extremely late. We just need to take the ones that were 1 day late and somehow move them over onto the green side, onto the positive side. So what can we find out about those widgets that were 1 day late? Maybe we can kind of partition the problem out a little bit. Maybe there's something in common about customers or about our bottleneck tools or something like that. Well, here's an example that shows us if we group this information by customers. So again, simply by putting customer on the color tab, we can actually break this out. The different colors are representative of the different customers. And again, by simply highlighting the legend, we can make these individual customers stand out. The interesting thing that we find out about this is that there are 2 customers that represent the majority of widgets that were 1 day late. So now that helps us to focus the conversation. What can we do to get an extra day from these 2 customers? Maybe we can negotiate with the customers to give us a little bit more time. Yeah, fat chance of that, right? Or maybe we can make it up in shipping. Some of these customers perhaps are international customers, and we can change our shipping mechanism in order to tighten up the delivery time, to make it up in the delivery time. That'll probably cost us a little bit more, but depending on how angry the customers are at us, it may be a cheaper solution than losing that customer's business. The point here is that we've really dug down into the information to slice it and dice it in different ways to be able to give us a specific path forward, some ideas to look at for how to have concrete ways of solving the problem rather than just throwing up our hands and saying, oh, for the last year we've had this big problem and I don't know what to do about it. The data helps drive the solutions. Very, very important concept. So the takeaways from this: first, there are really many, many ways of looking at the data. We need to look at the data in ways beyond the obvious. Tableau is terrific about providing the tools to help uncover that needle in the haystack. And never despair, the truth is out there. However, you may need to be Indiana Jones or Sherlock Holmes or somebody like that to be able to really uncover it. But you can be in your own way because nobody understands the manufacturing process better than a manufacturing person. So just start looking into that data, slice it, dice it, turn it upside down, shake it out, and you'll be able to find some specific paths forward. Manufacturers have lots of data, but none of it means anything unless we use it. And we certainly need to use it more effectively. Traditionally, only some people have access to the right data. We talked about that a little bit earlier. So there's got to be a better way. We've got to have broader access to the data that can lead more people to have more insights to drive improvement in manufacturing. In our perspective, what ultimately led us to our success was what we call curated data sets. And if you're familiar with the Tableau and Tableau environment, you'll know that these are basically server-based data sets. We call them curated data sets because we're like an art museum curator. We are going through the entire collection, we're finding the best information, and we're pulling it all together in a consistent logical format that our users, the engineers, the manufacturing people can use in order to create their insights. What we didn't want to have is our IT department become report writers, because the IT department doesn't know manufacturing. They're really terrific software developers, but they don't know manufacturing. So we need the manufacturing people to be able to have the resources that they need to solve the problems. Those 100 engineers, every last one of them needs to be able to have access to all the data that they need to be able to analyze and resolve the problems. So, curated data sets. We're looking at vertically focused data sets available on the Tableau server. And when I say vertically focused, the temptation is to create this big, huge data warehouse that does everything, but don't go there. First of all, the scope of the project is too large, and you'll never, ever get to that ideal. So rein it in and look at information like WIP, for example. Just show me the WIP information, show me the raw data, and then I'll slice it and dice it however I need to do. Once you're finished with that, then go on to, say, moves information. Once you're done with that, then go on to order and ships information. Then go on to scrap information. You kind of get the idea. Make this an evolutionary process rather than trying to stuff the whole pie in your mouth at once. Just do it in small bite-sized chunks. Second, optimize the queries and use a variety of different data sources. So we're trying to pull everything together in one bite-sized chunk that's relevant to manufacturing. And that may not mean that it's from the same data source. It may be coming from different databases in different places. But you can create the queries and optimize those queries to bring all of that stuff together so that the users will have access to it without having to do the data mining themselves. Next thing is to extract that data on a regular basis to the Tableau server. Now the Tableau server has all the data. It's optimized for its viz engine, and the performance of the whole Tableau environment is much faster, much crisper, and even better. The IT guys will love this. You're not querying against your data warehouse, and so you're not going to be risking 100 people hitting the data warehouse at once and bringing the data warehouse to a crawl. Common data keys defined across all of the data sets. So if we have WIP information and moves information, I want to be able to have, for example, the lot number as a key, as a data key that I can use for blending the two data sources. If I need 5 fields from this data source and 3 fields from that data source, I want to be able to have some common framework for blending them together whenever I need that. So be able to ensure that you've got some blending keys within all the data sets that you pull together. This is, I think, the most important one. Make it so that this is user data. It's not just your database field names and things like that, because this is cryptic and the data and the manufacturing folks won't really know what it means. Name these items consistently using terms that are familiar to your users, to manufacturing folks. Organize them into folders within the Tableau environment. Specify the data types. Within Tableau, you can define the data types. If something should be a %, make it a %. If something should be an integer, make it an integer. And you can create within Tableau descriptive tooltips. So if somebody's unfamiliar with what something is, they can just hover over it. They can see the tooltip describing what that particular measure or parameter is. And then finally, be able to define key metrics that are associated with the data. So if you have a standard definition for yield, define it, put it in there, included as part of your data set. Yield, cycle time, first pass yield, line yield, all of these normal standard manufacturing metrics get included in your data sources so that everybody's looking at the same set of data and everybody's using the same reference calculations. So you don't have the arguments in your meetings about whose data is right and whose data is wrong. So these are the data sets that we created. We've got inspection history, we've got metrology history, moves history. Again, this is tracking moves within the manufacturing system. We've got order history, revenue history, ships history, WIP history. With Tableau, obviously revenue history is SOX information in most environments. And so, but with Tableau permissioning, you can actually make sure that only the appropriate people see the revenue history and have access to that kind of information. But you can see we've got a broad range of information. So when I say these bite-sized chunks, that's kind of what I'm talking about. But with each of these, for us, lot number and or date time were the blend fields that we used in these, and we can now pull data from the different data sets together if we need to do that. So we want to make all this data accessible, we want to make it organized, we want to make it consistent. The naming conventions are standard across these data sets. We know where everything is, what's happening. You can see everything's logically arranged by folders. It's very understandable and very accessible and easy for all the users who are accessing that to be able to get to and to be able to do something with. Then we created some useful examples that were basically a standard set of metrics that we could use across manufacturing and morning manufacturing meetings, that sort of thing. But even more than that, they really served as the example for what the users could do. So we were using them to show the kinds of things that they could do and to use as template or hopefully inspiration for doing some things on their own. And they could certainly take these worksheets then and be able to kind of reverse engineer them to be able to use their own kinds of analysis. So the takeaway from this, get the data into the hands of all the people who can use it, not just those 2 or 3 or 4 who have the ability to write SQL queries and have the access to the correct databases, but give it to everybody. The more insights that we can have people having, the more solutions we can have for manufacturing. Make the data and the metrics easy for them to access. Lead with plenty of useful examples so that they have some idea of what the possibilities are, because remember, you don't know what you don't know, so show them. And finally, build confidence that the data is reliable. When we rolled out this product, we had some engineers who came back to us and said, well, this doesn't look right. So we'd go back and either look at the assumptions or look at the data itself. And sometimes we found that we had to do a cleansing process on the data. You would think that your manufacturing system has correct data, but we know that there's a lot of manual data entry going on, and so sometimes that's something that has to be looked at as you import things into your data warehouse environment. All right, so you actually have to get data analytics environment before you can use it or see its benefits. But the practical fact is that it is not free. So how do you convince the powers that be to fund an analytics effort? How do you sell analytics to the C-suite? That's always the key thing, because the folks in the C-suite are very, very focused on cost. They see that anything there's a cost is a bad thing. We're trying to drive cost out of the manufacturing process. You drive cost, you increase revenue, those are the big things. Spending really has to occur for things that clearly improve the bottom line. And any kind of justification that you do has to focus on bottom line improvements and return on investment. But for analytics efforts, it's kind of squishy sometimes, what kind of improvements we can get. But for manufacturers, I think we have it better than most because we are used to dealing with hard metrics. We're used to dealing with very quantifiable things. So it tends to be a little easier for us to know exactly how to improve costs, improve capacity, and improve productivity, because we've already got a history of already doing this and measuring our results. So let's take a look at a couple of examples for this. Let's take a look at an example for lowering costs. We want to lower raw material costs from better yield. We think we should be able, by analytics, to get some better yield. The premise here is that raw material costs reduce due to improved yield by more quickly identifying and correcting yield failures. So if we have an excursion in the manufacturing area, our engineers need to be able to jump on it very, very quickly and need to be able to dispatch it and get everything back up and running quickly. So our yield should improve, theoretically. Well, we can actually take a look at a matrix that uses the normal stuff that we normally use in manufacturing. How many orders do we have per month? What's our raw material cost per start? We know what our average yield is, and if we make an assumption based on the information, in this case the example was we think that we can do a 5% yield improvement by having better access to data and having more people access the data, and we just simply work through the numbers from there. Given a 5% yield improvement, we know exactly what that's going to do to our yield, so we know how many starts we have to have in order to get out the same number of orders at the end. And that drives into then raw materials expense, monthly raw materials expense, and we end up having a savings, obviously, if we're reducing or increasing yield. And we can then offset that savings against the cost of implementation of this system in order to come up with a payback period and an ROI. So in this case, in this particular example, the payback period was only 3 months, which is, you know, if the C-suite is looking at payback period for things, they're typically looking at, 12 to 18 months on things. And 3 months is really awesome. And, well, the ROI, they're looking at 200% or something like that, and probably nobody's going to believe your numbers, but you've got the data to support it. And 5% yield reduction in most cases is achievable. So here's another example. How can we improve capacity? We want to have more ships from improved constraint tool capacity. So if we can have more capacity from our bottleneck tools within the manufacturing environment, theoretically, we should be able to ship more product. In this case, by improving yield, we're having more runs or moves through those constraint tool sets, and so that should free up a little bit of extra capacity. So same thing, we just run the numbers. We know how many orders we get. We know how many times it takes to process that order through a constraint tool set. We know what the impact of yield is, so we know how many moves we have to go through those constraint tool sets based on the existing yield numbers. And again, with that assumption, okay, we think we can improve yield by 5%, then it's just a simple, straightforward calculation at that point. We should be able to drive all the way down to how much additional product we should be able to get, what our additional capacity should be for the factory, and then we know what the average selling price is. We can translate that into additional revenue, offset against the expense of implementation, and now we get, same thing as before, we get a payback period and an ROI, all positive in this case. Now, your management team may not believe you. They say, okay, well, yeah, we've got improved capacity and we can sell, say, 1,000 extra widgets a month, but we don't really have orders for 1,000 widgets per month. So what we did in this case was we scaled it back a little bit. We said, okay, we're going to assume that we need that excess capacity in only 2 months out of 12. 10 months, we don't have enough orders, we still have less capacity, but in those extra 2 months, we actually need it. So we simply run the problem based on 2 months rather than 12 months, and we still end up with a positive ROI. So very, very good example. And again, your C-suite team is going to ask you exactly that. They're going to challenge you with that kind of information. And then the final example, how do we improve productivity? We're really trying to get productivity gains for the existing staff so that they can dedicate more time to more productive activities. And in this case, I'm sure everybody in this room knows what it's like to sit down in front of an Excel worksheet, try to get the data, massage it, cleanse it, slice it, dice it, pivot tables, charts, PowerPoint, the whole stuff that we normally do. We all spend a lot of time on that. If you could get each of these constituencies to just save a half an hour a day, just a half an hour a day by making the process easier. We won't even talk about making it so that they can come to better insights, but just save a half an hour a day from that tedious Excel-based process. There's a real savings there, and it really adds up. Even though it doesn't seem like much, over time it could really add up. So we're doing the same kind of analysis. We know what the salaries are, basically the hourly rate. We're assuming that we're taking vacation time out of that because we're not getting any productivity based on vacation time. We know what then if we save that half an hour per day, we can calculate how many hours, extra hours per month or per year of productive time we would have from these folks. And again, just multiplied by the hourly rate, we can get that particular amount of productivity out of these people. Now, productivity is a soft goal. The C-suite folks, they understand more revenue. That's very clear. They understand less costs, lower costs. That's very, very clear. But productivity is squishy. You know, I got more productivity. Hey, you're salaried, right? I can work you more. That's more productivity. But is that going to improve revenue? Is that going to lower costs? Maybe. Not necessarily. We don't know. So it's kind of a squishy metric with this. And so it's probably not the only metric that you want to use when you're presenting this to your C-suite folks. But again, it doesn't take a lot to be able to convince that a small change can have a relatively large impact on helping to improve the environment for everybody. So in this case, again, you run the numbers, you see what the productivity enhancement would bring from a dollar standpoint. You see what the implementation cost is, and again, it has a positive ROI, and it's smaller than the rest. And in the end, you want to come up with a summary chart that shows all the options. This is what you'd present initially to your C-suite folks, and then use the other worksheets that we saw just previously as more reference information in case they have specific questions about the assumptions and how the numbers were generated. But this clearly shows exactly what the ROI of this kind of project is. All right, so it can take some time to warm up the C-suite to spending money. So if they're kind of lukewarm to the idea, be patient. Give them some time. It does take some time. You'll have to work on them a little while, so be patient. In general, capital purchases, that is to say spending lots of money, and large deployments of Tableau can be capital purchases in a lot of companies. This takes time as well, so again, be patient. It has to go through that process. It often helps to spread the implementation over time in order to ease the cash flow. Maybe add some desktop licenses and a server implementation one quarter, then beef up your server implementation and add some more desktop licenses, and in a year, you know, you're where you want to be. So that can really help, but again, it requires patience, so be patient. The C-suite folks need high-level examples so that they know what they're buying, but they don't need a lot of detail, so don't tell them because having access to this data, you're going to increase the yield by reducing the current threshold through this. You know, they're going to glaze over and they're going to go, yeah, thanks. Next. So don't go there. Keep everything very, very high level for them. But at the same time, don't patronize them. Stay focused on the bottom line. Stay focused on the actual value and the ROI. And be patient to help them understand the benefit. All right. So we've gone through a 2-year process to get to where we are today, and we've seen some really terrific results and terrific benefits from this process. We believe that we've tamed our data, and it really has had some great results. We've made data more broadly accessible and easier for people to turn data into information and to turn information into insight. So along the way, we've learned and understood a lot, but hopefully we've also developed a bit of wisdom throughout the process. So I want to share with you some of the lessons that we've learned. Analytics are not an IT project. The business has to be integrally involved, and it has to be invested in the effort. You have to start with questions. What kinds of problems are you trying to solve? Don't start with data. That's like trying to find a question for a solution. We need to start with the questions. Keep your initial implementation modest. If you try to bite off too big of a chunk, it's just too overwhelming. You'll never make it. So start small and grow things from there. Keep the initial implementation successes frequent and visible. So show people what you're doing over time. Make sure that people can see these things. Determine your implementation objectives and your ROI early on in the process so that you can begin to educate other people to the benefits of this. The resistance of the C-suite is typically due to the lack of proven ROI That is to say, somebody that's already done it in your company. So it's a chicken or the egg proposition. You have to figure out which one that is in your company. But again, using the kind of data analysis that we showed before, you can show clear ROI from this kind of process. Keep the C-suite engaged. The projects that you do initially have to have them in mind, whether it's revenue over time or other kind of financial metric that they can understand and they can work with day by day. Incorporate that into your project plan so that they can continue to feel invested in the project and see the benefit as you grow the environment. Make sure to review and cleanse the data regularly, your source data, garbage in, garbage out. Boy, that's a phrase from the 60s that just hasn't gone away. As we see it in big data more and more, it still exists. So make sure to look at it. Training is important for all of your users, but ultimately evangelism is more important. You have to convince people that there's really something here, and there is. So make sure that your successes are visible as well. And finally, it's good to remember that analytics are new to a lot of people, and it tends to be scary. Ooh, analytics, data science. It's not. We want to make sure to get these capabilities in the hands of the people who are already doing this kind of thing. They're just not using this tool, and this tool can help them become much, much more productive. In the end, data is irrelevant without the context of questions. Good questions are really the key to determining what data is needed and exactly how to use it. So for the presentation today, the key takeaway, it's all about the questions. We have to make the data available to as many people as possible, and above anything else, we have to make the data actionable. In the end, it's not about how elegant your solution is or your analytics capabilities. It's about what you do with them, and that the results you get are actionable and they really count in your manufacturing area. Thanks a lot.